All right. So since you have watched the video where we explained what confidence interval is, we'll go on to solve questions involving confidence interval, and you can find this in this Excel files in your module. And we'll start with the first one. If you remember, one of the core things we've said is that when we deal with confidence interval, there are several ways that we can solve confidence interval. For this week, we're going to look at solving confidence interval when we have large sample size and small sample size. The large sample size means that you have a sample of 30 or more, and a small sample is when you have less than 30. Now, the way we solve questions involving these two are different, and I'm going to walk you through the step and show you how different they are. Now, when we are solving questions involving large sample sizes, we tend to use what we call z-test. When we have small sample, we use what we call t-test. As you know, the z-test is very effective in solving questions. We've used them in normal distribution, but they tend to work less effectively when you have a small sample. And for that reason, we use what we call a t-test. A t-test is actually more effective when you have small numbers. So small values will be more effective with a t-test. Now, another reason why we'll choose to use either a z-test or a t-test is also when we have a population standard deviation known or when it's not known. Now, if I know my standard deviation, my population standard deviation, then I use my z-test. If we are not given, or we're using the sample standard deviation, then we use what we call a t-test. So a good way to put it is that z-test is used when you have large sample sizes that are 30 or more, and when you have a population standard deviation given, while t-test is used when the sample size is less than 30, and when you have maybe a sample standard deviation, or a better way to put it is when the population standard deviation is unknown. And so for this first video, we're going to go ahead and solve questions that have to do with using z-test. That's when you have a large sample size and when the population standard deviation is known. In the next video, we're going to look at how do we solve questions where you have a sample size that is less than 30 and where you have the population standard deviation unknown. And by the time we're done with this, it would make confidence interval even easier than you originally thought it was. All right, so let's solve a couple of questions. And we're going to address these questions slowly and surely so you can understand how to solve them. Let's look at the first one. We're told that a college admissions director wishes to estimate the mean age of all students currently enrolled. So what we're saying here is the administrator does not know the average age of her students, right, in the whole school. And that's a population, right? So she wants to know what the average age is of all her students in the whole school. Now, because she's not able to ask all of them for various reasons, maybe for time, maybe logistics or other issues, she decided to what? Sample 30 students, right? And when she sampled the 30 students, she now found the age to be what? 22.9. Now, we know that the sample size is 30, right? So we can say that our n is equal to 30, and that n stands for the sample size. So she did a sample of 30 students. Now, she found the age to be what? 22.9. That is a number from the sample. And so that would be the sample mean, right? Because that number is from the 30 students. So she asked the 30 students how old they were, and she found the average of that to be 22.9 years. right? That came from the average. And we are told that the population standard deviation is given as 1.5. And so we're going to say the population standard deviation is given as 1.5. And we're told the population is normally distributed. Now, students will sometimes say, oh, but it doesn't say here. Well, because the whole sentence ends with, and the population is normally distributed, we're assuming that the population standard deviation is what is given here. If it wasn't, it would have said sample standard deviation, or it would have made reference to the sample. But you see, the sample ended here with the period, and then we started with the standard deviation. So we now have the sample size, we have the sample mean, we have the population standard deviation, and we also know that the level of confidence, right, is given as 0.95. If we know that the level of confidence is 0.95, we know that the alpha, right, the part we don't know would be what? 0.05. So you can see, right, what we're now told to do now is to find the margin of error. And if you remember what we said, right, when you want to find the population mean, right, and you can't do that, right, what you do is you take a sample, which we've done, of 30 students, and we found the mean, or given the mean as 22.9. We now want to find an interval, right? That's the end game, to find an interval where we think should contain the population standard deviation with a confidence level of 95%. But the question is not asking us to find the confidence interval, it's asking us to find what the margin of error is, which helps us find the confidence interval. So let's start with finding the margin of error. The margin of error is actually quite easy to find because we know a few facts, right? For example, we know that this is steady, so we know that it's most likely a z-test. We also know that we're given a standard deviation, and so we know that we're going to solve it using a z-test. That makes it easy for us. So our margin of error will be equal to, we would select our confidence, right? And you can see, because we're using z-test, we'll do confidence.norm, right? Confidence normal distribution. And so it tells us what to do. It says we select alpha, which is this. It says we select our standard deviation, which is this. And it says we should select the size, which is 30. And that's all. So we know based on the questions, right? If we're going to do this, we now know that the margin of error is 0.5. With this, we can easily find the confidence interval. But this question is not asking us for that. So let's move to the second question. The second question now says, well, based on what you've learned from question 1, now construct a 90% confidence interval using the same population, right? So this becomes easy for us. So I'm just going to copy some of this stuff here, and then we're going to write down what the values are. We know this is steady, which was given to us. We know this is 22.9, which was given to us. We know that the standard deviation is 1.5, but we were told that the confidence interval is 90%. And so that's the same thing as 0.9. In that scenario, our alpha will be what? 1 minus that, and that is 10%. Now, to find the margin of error for 90% confidence interval, it will be equal to, right, confidence norm, because we know that it's using z-test, right? We'll put our alpha, we put our standard deviation, and we put our size. And so you can see our margin of error is about 0.45. Now that we find our margin of error, remember, right, to be able to find the confidence interval, remember, it's supposed to be your sample mean plus or minus what? A margin of error. And so we're going to look at what is our lower interval or endpoint. We're also going to look at what's our higher interval. Some books will say upper interval. Right? And so if you do higher or upper interval, you're also going to be correct. To do that, right, remember, it's our sample mean plus or minus margin of error. So for this one would be our sample mean minus a margin of error. And for the second one, it will be our sample mean plus a margin of error. So you can see that our confidence interval is written, we can write the confidence interval as 22.45, right? And 23.35, right? And we know these are in years. So we're now going to interpret the results. And this is where understanding the concept is very important, right? So we can say that we are 90% confident, right, that the population mean age of students at the college, right, this college, right, lies between 22.45 years and 23.35 years. Right? That's the whole essence of the confidence interval, right? So we're 90% confident that the true population mean will lie between these two values. And by doing so, we have done a couple of things. We've found the margin of error, and we've created a confidence interval for this question. All right. Now, I hope this makes sense, but we're going to try a couple of examples just to make sure that students understand this concept even better. So I'm going to pick something that we can look at. So I'm going to move to question 7. And question 7, the reason why I want to use question 7 is that it also goes to things that we are a little bit comfortable with, right? So here, what we're doing is we're saying, okay, what if you randomly select, and let's assume that you are someone who works in the business and you want to find out what the average price of a home theater system is, right? So we're going to go with that assumption. And so in this case, you selected 34, right? Home theaters, right? And the sample mean, right, of those 34 that you selected is $452.80. And you are told that the population standard deviation is given as 85.50. You're told to construct a 90% confidence interval. You know, based on this question, that your alpha will definitely be 1 minus this, and so that comes up to 10%. So kind of similar to the question we did, right? So here you're asked to do the same thing, right? And we know that our margin of error, which is our E, yeah, when you do this, this always turns out to be an issue. So our E will now be equal to confidence, and that's because we know that our sample size is 34, which is more than 29, which is 30 or more, right? And we also were giving population standard deviation, so we know to select this one. And so you have your alpha, you have your standard deviation, and then you have your size. And so you can see that the margin of error is about $24, right? And so if you are asked to do your confidence interval, we have to do a lower, and then we have to do an upper, right? And the same process works. It's going to be your mean minus your margin of error, and also your mean plus your margin of error. So if you are creating your confidence interval here, which we're doing here, we can see that our confidence interval lies between $428.68 and $476.92. But remember, right, in statistics, we always want you to interpret your results because you are always going to be, or not always, you might be in a scenario where people who you work for, who are your higher ups, may not understand statistics. And so your goal is, how do I explain this in such a way that they can get some understanding of what I just did? And so we will say that we are 90% confident that in this case, we're looking for the population mean price of theater systems is between $428.68 and $476.92. Let's look at another example where you might be giving just more than the basics, right? Where you're asked to test and see if you truly understand this in detail. And let's look at question 9. The reason why I want to do question 9 is that question 9 doesn't just ask you to interpret your results and to provide your confidence interval. It actually asks you a few other questions to kind of see if you understand this concept even in detail. So here we're told that a random sample of 55 standard hotels a room in LA have a nightly cost of $154.70. And I wish I could find something that cheap, right? And a standard deviation of $38.60, right? Construct a net confidence interval for the population mean cost. So you're asked to find the population mean cost of that. Interpret the results. It now says, is it reasonable for the LA Hotel magazine to assume that the mean cost of a hotel is $139.75? How about $167.25? Now it says, explain your reasoning or conclusion. So this is where we actually test to see whether you understand the concept. We're not asking you only to find the interval, but we're asking you to go ahead and test that concept and see if you really understand it. So the same thing goes here, right? In this case, we have 55 rooms, so we know that we're dealing with a question that is about z-test, right? And we're told that the sample mean here is $154. So our sample mean is $154.17. A standard deviation here is given as $38.60. And we're asked to construct a confidence interval of 99%, which means that our alpha, which we will need, is going to be 1%, right? So we kind of have everything that we need to solve this question. The next we need to do now is to find our margin of error, which I'm guessing we are experts now in solving them. So margin of error in this scenario, since we know we're dealing with the z-test, values 30 or more, population standard deviation is given, we'll now say a confidence interval. And so we will select our alpha, we will select our standard deviation, and then we'll select our size. And so we get that answer as our results. So now that we've found our margin of error, we can now find our lower interval, and we can also find our upper interval. And for a lower interval, like we said, right, it's going to be sample mean minus your margin of error. And for our upper one will be sample mean plus a margin of error. All right, so our confidence interval will be between $140.76 and $167.58. So confidence. All right. So, but there's something missing here, right? We've done we've done this part. Now we have to interpret the results. So we can interpret the results and say, okay, same thing, right? We are 99% confident that the population mean cost of standard hotels in LA lies between $140 and 76 cents and $167 and 58 cents. Well, that's just the first part. Now we have two questions to worry about. Now, the first one says, is it reasonable for the LA Hotel magazine to assume that the mean cost of a hotel is $139.75? Now, what we need to notice here is that $139.75 is outside the confidence interval at 99% confidence. So it clearly shows us that it's not reasonable. The magazine assumes that the mean cost of a hotel is 139.75, then it's not reasonable, because at 99% confidence, we know that it should be between 140.76 and 167 and 58 cents. So we'll say it is not reasonable for the LA Hotel magazine to assume that the mean cost of the hotel is $139.75, because at 99% confidence interval, this amount is outside the interval. Or we can say because it is outside the 99% confidence interval. That's a better way to put it. But look at the second one. How about 167.25? Yeah, it is, because it ends at 158 and 167 at 58. So yes, here we can just, it's the same thing, right? So I'm just going to go here. I'm just going to be a little bit lazy here and copy this. And I'm just going to paste it here. And I'll say that it is reasonable. But then let me just assume that the count is, I'm going to go and just fix this and say 167.25, because it is within the 99% confidence interval. So I hope this helps you understand how confidence interval works. And I hope that the examples we've created here and questions we've solved, question 1, 2, question 7, and question 9, helps you understand how to create a margin of error and also to create a confidence interval. But before I go, I want to solve question 3. And I want to show what question 3 is. Question 3, what question 3 does is it's asking us to do a sample size. Now, one of the things about confidence interval is we use it in a lot of things. A good example is when you're trying to do a poll or a survey, right? You want to know the number of, at least the minimum number of sampling you should need to sample to be able to get the results within a certain margin of error that you're looking for. So in this case, it says that you want to estimate the mean number of friends for all users of your website. Now, how many users must be included in that sample if you want to be 95% confident that the sample mean is within 7 friends of the population with a standard deviation of 53? So what's happening here is that you want to be able to see what's the average number of people that use my website, right? What's the average number of friends for all users of the website. But to do that, you need to know what is the sample I need to take to be 95% confident that whatever result I get as my sample mean falls within 7 friends. That within 7 friends by default tells you that that is your margin of error, right? Because it's within 7 friends of the sample mean. Remember when we are solving, remember we say that margin of error, right, is within plus or minus, right? And so when it says within 7 friends, you know that by default, so 7 and 7, by default, you know that this is going to be your margin of error. We also know that our standard deviation from this question is given as 53. And then we are told that we are 95% confident, right? Now, what we're not giving here is, we know the formula. Remember the formula for your sample size is your Z value times, right, your standard deviation, right, over your E, and this is what? Squared, right? And so you know what the formula is, right? So this times D, standard deviation over your margin of error, and this is squared. And so we have a few things, right? We know our standard deviation is given. We know what our E is. We just don't know what our Z value is. Now we can find our Z values quite easy, right? It's not a problem to find our Z value. So let's go ahead and find our Z value. Now, remember we said our confidence interval is 95%, right? And that is going to help us in solving. So one thing to remember is that when we say that we're 95% confident, right? In theory, what we're saying here is that we're 95% confident, which means that our percent that we are not confident, right? Or our alpha here is going to be 5 divided by 2. So you have 2.5% here, you have 2.5% here. So if you are going to convert this into your Z value, what you're looking at is a scenario where you need to be able to use your values all the way from here to this value. So everything here. And so you can see this is your 2.5 plus your 95. So what you have here is what? 97.5%. Now, in the exam, you don't have to worry about this because we provide you the Z values, but I just want to show you how we're able to convert our confidence interval into Z values. So your 95% confidence is right here. And remember, because it's 100%, so there's 2.5 here and 2.5 here. And so we add that, this value here is actually 97.5, right? And that helps us when we're finding our Z value, because we can now say, okay, in order to convert, right, a percent back to a Z value, if you remember, it's really a non-inverse, right? So you're doing the inverse of that. And so that would be 0.975, right? 0.1. So your Z value gives you 1.96, right? So now if we're trying to find this formula, it becomes easy, right? Because then to find our sample size will be equal to our Z times standard deviation over our E, and then whatever we have here, we're raising it to the power of 2, right? So you can see Z is a C10 times standard deviation, which is C8, divided by our margin of error, which is C7, and then we're working the square of that. And so that gives us an answer of 220.218. But because we're doing a sample of people, we tend to move this to the next whole number. And so what it means here is 221 people or friends. Right? So the mean number to be able to do that, or can I say 2 number of people or 221 users. And that's how we solve questions that involve using or finding sample size. I hope this makes sense. as you learn and solve questions. I'm going to give you guys a chance to get some extra credit, and I will provide you with 2 questions that you can try. And based on how you understand this question should be easy for you to do. All right. So we're going to have you try questions 11 and 12. Question 11 allows you to kind of think about this question in some detail, and then question 12 does test your understanding of this topic, right? So we'll do question 11. So question 11 and question 12. And so you can submit this by Saturday, and that will let us know how you understand this topic. If you have any questions, feel free to reach out. Thank you, and I hope this video was helpful.